Okay, hello, this is Jens speaking, Genius Graphics, and today's presentation is Tecplot 2016, how to save time by automating your post-processing workflow. In other words, it's about macro programming basics. My name is Jens Wakal and I'm a physicist working with Genius Graphics. Some remarks about this webinar. Currently, you all are muted. Nobody can speak to me. But in the later process of this meeting, we will give you the chance to speak. You have additionally to your microphone, which is currently deactivated, the opportunity to raise questions via chat. Or what you can do too is to raise your hands. This will be done later in the question and answers round. Okay, let me start now my presentation. Summary. I will speak about why to automate your post-processing, what's the reason for doing this. We will speak about style sheets, layouts, and macros. A little bit what are the differences, then about the documentation, and what is the working practice to build a macro. I will show you some important commands and variables, and then I will directly create a little macro to show you that there's really no reason to hesitate creating your own macros. We will learn something about the macro debugger, which is now in a new version available in Tecplot 2016. And we see a little example for some important commands and how you debug your macro. After this, we will have a look at the quick macro panel. What's that? And then we see some more directly examples of macros in Tecplot. Then we will have, as a last step, we will see Tecplot Chorus working with a little macro. It's an integration example where I integrate over surfaces. And then I show you whom to contact if you have any questions. After this, we will stop the video recording, and then we will have time enough for question and answers. So let's start. Why to automate your post-processing? The first reason, of course, is simply it saves time. The second is, let's say it's easy on the nerves, because if you have to repeat constantly the same steps, that's really annoying. It allows you very complex operations, for example, to access data in every data point or to have control structures, if then else. Additionally, you maybe directly include the macros or in your workflow, and for this we additionally have batch processing. This can be used in report generation. Style sheets and layout files and macros. So you will know from Tecplot introductions what are style sheets and what are layout files. And yeah, well, they are easy and powerful to save the work done. Yeah, the style sheet for frame, the layout file for the complete work, or as a layout package. But if you want to have dynamical actions, then you need macros, because they have user interfaces. We will see them today. We will have loops available. We will have conditional statements, control structures, if then else, for example. We have extraction of parts, and yeah, you can then further work on those parts, like to create integrations on those surfaces or slices which extracted. Okay, the new functionality then can be placed in the quick macro panel to have it available on the fly for, let's say, often repeated tasks. The documentation about the macro language. Well, it is given in the so-called scripting guide, where we have chapter 7 for macro variables and chapter 9 for the macro commands. And chapter 10 is interesting for some sophisticated functions which are not available in the standard macro language, and this is called the extended macro. And then additionally something if you have to do with transient data with time steps, that's the user manual. There you will find the extended time macro. Let me show this directly. So this data set we will later have a look at. Where do you find the documentation? In the so-called welcome screen. So click here on view, welcome screen, and then on the right side you will find PDF documentation, which is definitely at least my recommended documentation style. And here we click on the scripting guide, and then I switch in this PDF viewer to excuse me. So here we switch to the mode. Yeah, this is the correct mode. Here we see all the functions, and for example, chapter 7 for the macro variables, where internal variables are very interesting. Those are variables which are included in Tecplot and where you have always access to. And additionally, chapter 9, for example, is very important because here you can look for macro commands. Perhaps you forgot one and you would like to know the syntax of if and so on. This can be found here, and 10 is extended macro commands, which you might want to use. Okay, I let it directly open because I need it today for my macro coding. These are some commands of the extended macro. So for example, if you are pretty familiar with macro programming and you would like to work with strings, like that you have a path and you would like to extract something from that path string, then you will find here string find pattern and so on. Or if you want to know which zones are active, then you find here query active zones. So you should definitely have a look at this extended macro if you feel limited in the standard macro language. Some working practice. What you will do is to record a macro, so Tecplot does the main work for you. You will not learn every command in this Tecplot macro language because there are hundreds or thousands of commands, and the most of them are recorded from Tecplot, so you will not learn anything about them. I would say if you, in your working practice, know let's say 20 commands, or perhaps, yeah, I think 20 commands is enough. And you know where to find those commands because the parameters and so on of the commands, you will not remember them. So just check the documentation. That's enough. The rest is done by Tecplot, so Tecplot does the main work for you. You will clean up the macro. Why? Because you will remove unessential commands. I will show you an example because if, let's say, you zoom in into an object, then Tecplot will record dozens of zoom factors and so on, and those are not interesting in macros. What you want to have in a macro is some functionality, and all the optical things are done in style sheets. Then, after having cleaned it up, you will add commands which are not recorded, like loop if prompt. There are different prompt commands, var set, and so on. If you have a complex macro and you want to have a better overview, then I would recommend to use sub-functions, which can have parameters, and those sub-functions, for example, could be organized in an external macro, and this macro can be included with include macro, so that you have a complex macro split up into easy parts. Then you will test your macro, and it may of course be that there are some bugs included. So a standard way is then to simply check the error messages, and if this is not enough, then check the variables when you debug your macro. So you have a debugger which you need in some cases. If you will often use your macro because it's a pretty standard macro and the tasks are repeating very often, then of course feel free to place them in the quick macro panel, which is easy to do. I will show you later how this works. Some important commands. Var set is a very important one, where you create your own variable, which here in my case is called myVar. It can be any name, but please be careful with the internal defined names, they cannot be used. Then you use this pipe sign symbols here for the syntax of Tecplot. This $! is needed in the Tecplot language. And then, for example, here you define the text or number. The looping command loops over the loop counter, which may be a number or a variable. Let's say it's a number 10, then it will go from 1 to 10. So not from 0 to 9, like in other languages. We have if, else, if, else, and if for control structures. We have a pause command, which you can use for debug messages, for example, or if you want to display something for the user, then use the pause command. Prompt. Prompt are user interface commands where we have 3 different ones. For text string to read text, maybe, for example, a number which you type in. Prompt for yes, no to check an answer, and prompt for file name if you want to select a file. Get field values, set field values are very important commands if you want to have access to single points of your data set, and then you can read out the field values from those points. Important internal variables are, for example, num zones, which is the total number of zones, the num vars, which is the total number of variables. Then we have loop, which is the loop counter. This variable is only defined if you are in a loop. And we have macro file path, which is very handy to use. This includes the path to the macro which is currently executed. So if you have let's say sub macros which you would like to include with include macro, and they will have an absolute path. They don't need an absolute path, because then you use macro file path, because this automatically is the same directory, and if you move the complete structure, the file structure, then this still works. Max and mean, there are different ones. Max x for max I, for example, for the maximum I, and so on. These are extrema of variables which are often used in your macro language. But you will learn more if you gain some practice. You can create batch jobs with your macros. So this is described in the user manual chapter 27. But it's so easy that I just can explain it here without showing you something. You just start Tecplot with text360 -b. It stands for batch mode -q. Now comes q stands for the macro which follows now. And then you write the the macro name .mcr, and the last command in the macro should be quit. to leave that macro and to close Tecplot. Naturally, you shouldn't use prompt commands in your batch jobs, otherwise the Tecplot window pops up and then it's an interactive session, and this is exactly what you wanted to avoid using the batch job. Yeah, let's start with a simple example, a very simple example, by the way, but nevertheless, it should show you that you never, please hesitate to write your own macros. We create a little cube, and then we will copy and translate it, and we will have the freedom to say how many of these cubes should be copied and translated. So let's start, and for this, I start a Tecplot session, and I start with an empty sheet here, and now I create a little cube. Okay, that's done. And now I will start to record my macro, because I would like to copy this cube and then to translate the cube. Record macro. And then let's call it cube 1 or something. Note that the auto redraw is disabled during macro recording, which means that if you are doing some changes in the graphical style, like switching on contour, you will not see it on screen. This does not mean that it doesn't work. It simply means that you need to click on redraw. Okay, the macro recorder starts. And what we are doing now is to create a copy. So we duplicate the first zone, create. Now those both zones are in the same position, and I would like to translate the position of the second one. So x equals x plus 1. Compute. And now you see that it's needed to redraw to see what happened. Okay, we have a second cube and it's translated, and we can stop now the recording, because the rest has to be done interactively. But nevertheless, I would like to show you what happens if you now do some graphical things like translation and zooming in, zooming out, and so on. I stop recording, and now I would like to open the macro, which is called cube 1. And it starts with a command which I can delete. Var set whatever. When you see duplicate zones, this copies the zone and alter data, which is the x equals x plus 1 command, and all of the rest here is something which happened because I zoomed in, zoomed out, and so on. And this is what I mean with cleaning up a macro, because all of this rest here is not needed. These are the only lines which are needed. Yeah, and what we would like to do now is naturally to loop. Yeah, so let's say that you loop over 10. This is one of the commands I can remember. Loop. Yeah, so it ends with end loop. It's different than, let's say, Python. Here you have starting commands and ending commands in some control structures or in loop structures. And this now would duplicate the this zone 10 times, and the source zone can always be the one. The destination zone, this is something you should note, is not needed because I give this command the freedom to translate the cube to zone position wherever it likes to have it. Normally, of course, the end or the numbering of the zones. Okay, alter data. This, of course, should be for the first copy. It should be number 2. But if you copy it twice, it has to be the 3. And then this here should not be x plus 1, but x plus 2. So in the end, if this loop starts from 1 and goes to 10, then we have here x plus loop, which is the internal variable for the loop. And alter data 2 is not correct. This is the same as loop plus 1. And so we need here a little, let's say, helper variable. Varset is another command which I told you is very important. Yeah. So you should remember this command. And here we simply now write something like x. No, sorry. It's the zone number, and this is nothing else but loop plus 1. It should start from 2. I write now ZNR, and that's it. And this macro now should create 10 copies and shift them if there's not a little bug. But I don't think so. Let's try it out. I delete the second cube. And I start the macro. Here we are, and we should have now 11 cubes. Yeah, you see that's very easy, but this is not the solution of our problem. We would like to use now an input. How many copies should be created? So I'd simply copy and paste one of the prompt commands, which is prompt for text string, and so that's it, prompt for text string, and I paste it to the top. Prompt for text string, NR copies, number of copies. How many copies? And we place here the number of copies. That's it. Save the macro. Run it again. Data delete zone 2 to 11. Run the macro. How many copies? 50. Yeah, and now Tecplot cuts the screen because this is too long, and if you rotate a little bit, then you see there are a lot of cubes, and if we check it here, we will see 51 cubes. That's it, so easy. Well, this is how it works, so don't hesitate to write your own macros, and you see here, this did the job 50 times, and perhaps you have things, tasks where you need 1,000 steps or something. So you can imagine this should not be done manually. Okay, back to my presentation. Okay, that's it. And now about the macro debugger. And we have a new version in Tecplot 360 EX 2016, and I will try it out with a macro, importing some functions and variables. And yeah, well, let's perhaps first check the source code. So we have a sub function which defines some variables. Then we have a sub function, and this sub function calls the sub function. And then we are prompting, for example, for file name, for text string, for yes and no, so that you learn a little bit about the different prompts we offer. And then we have a decision here, depending from yes and no. And so in the end, the macro is doing more or less nothing, but it shows you how to work with the macro debugger. Okay, let's start that macro in Tecplot. So first, perhaps you create a little zone, like this rectangular one. Plot, shade, or mesh, or whatever. This is not very important what we have here as a zone. We are going to scripting and view debug macro. And now we load the macro, called test macro. And now we find here several variables which come from zones I loaded before, so I did not start up with a fresh Tecplot, but this is not a problem. We can simply type in here the variables we are interested in. So we have a single step here, step into, step over, and step out of functions. This is to run or continue the macro. This is to reload or reset the macro. This is to load a macro. This here are typical breakpoints. So let's put a breakpoint here, and let's put a breakpoint here. And we can check, for example, some variables like file name. You see, I run that macro before, that's why this is defined, otherwise it would not be defined. Input, it's currently set to 56. Once again, this would be normally not known, that name, if or let's say not defined if the macro wouldn't have run before. The choice here, if you like to, you can check the loop, which is now really undefined because we this is only defined in the loop itself, and the loop is currently not running. Yeah, okay, I think this is enough. And now let's start to run the macro. We can, for example, run or continue here, or step into. So let's do it step by step, that you see how that works. I load an image. This is not an image, but this is just a file name. And you see now this is here defined. If the input, the input is the next. So step, you see here 56, and type in there whatever. See it changed. So this is how you check the variables. The choice here is currently no. This is this choice. And we are prompting for choice. This means I will prompt now. Should I begin with a loop? I say yes. But now I would like to run. So not to to make it a little bit faster. Loop counter 2, loop counter 3. You see the loop counter here. Loop counter 4, 5, 6, 7, 8, 9, 10, and now we are out of the loop. We step to the next functions. You see loop is now undefined. Now we come to the first subfunction. And here you see now the macro source, and we are now in the call stack in the subfunction. We can check the value of temp if you like to. So here temp is 5, and we are now here, little pause, and we are stepping now into the next function, into the sub function, and we expect it in the call stack. Yeah, here we are, sub function. This is your sub function, and if I finished that sub function, I will jump back to the main code and I will leave the macro. So that's it. The macro is finished, and we see that the call stack is back to main. This is how the macro debugger works, and I forgot to say the breakpoints are here, so you see where are your breakpoints, and feel free to delete them here if you don't need them anymore. That's it about the macro debugger. I would show you now the quick macro panel. What does this mean? The quick macro panel is available on Tecplot here. It's available if you check the scripting, then here the quick macro is activated, and in the modern version of Tecplot 2016 you have it on the you can place it here, or with Qt of course you're free to place it here. So this is now a different structure. Yeah, you see I can simply dock it in here. Okay, that's the quick macro panel, and what can you do with this and where do you find it? It's very easy. What I did, calling here Tecplot, is the following. This automation is what I started. This is nothing else but a standard Tecplot where I changed a little bit the parameters to call it. And you see here that I start Tecplot with -QM, which stands for quick macro panel. I don't use the standard macro panel. I wrote my own one. And this is here under D, webinar, and so on. And let me show you how it looks. So the my Tecplot MCR, this is a macro. You will find in your Tecplot directory in your installation a file which is called tecplot.mcr. This is a quick macro panel, and you need nothing else but to take your own macros, to copy and paste them into this quick macro panel like here. And the only difference is that they end with end macro function and that they start with macro function. Then you have a name here, which in my case is slice over time, and show in macro panel can be false, then you will see nothing, or true, and then you see a button. That's all. So easy. Yeah. So this is a little change of the default tecplot.mcr file. Feel free to change the standard file, but often you have not the right to do that. So you can do it for your own, and you can create your own files, put it in your home directories, and call them in this way that you use a parameter. Well, that's the quick macro panel, and it's really nice for repeating tasks. And let me show you an example. First, back to my PowerPoint presentation. Well, I will show you in the end of this webinar now. We are coming to the end. Some examples: extract boundary layer from aerodynamics, yeah, and averaging slice over time point by point. This macro, for example, I placed it in the quick macro panel to directly call it. First, to a pretty complex tasks, it perhaps looks easy, but if you have to do with aerodynamics, then it may be clear that this is not an easy thing. I have here an airplane, and on the wing, I would like to know a variable, for example, pressure or whatever, and I would go into the normal direction of the wing. And so what I need to do is to create a normal on every point of the surface. Then I go into the normal direction, and I extract from the 3D volume, which is around. You can't see it here because it's not sliced, but it's around. I can show you. Yeah, so if we place a slice here, then you see that we have a volume slice. And I want to know the boundary layer of this wing. Yeah. So let me start that macro. Before I start, I probe. I want to know a node number where I check this value. Let me go here. I click to probe. I see, for example, this is node number 126,000 whatever. I copy and paste it. I start my little macro. This is called this one. I open node number, okay, zone number 12, you can see it here, zone 12. The profile height is 0.01, and the variable which I would like to plot is number 4, and after having done this, I directly get a plot of the boundary layer in the normal direction. So this would be really a tough task for you to do without macro. Well, second example, I will load a transient case. Let me load a transient data set for this webinar here. It's from Fluent. I load one, I think it's 20 time steps. And now we do some typical optical changes, activating edges, switching off, shading, switching edges to creases, and place a slice. Okay, and for example, for this slice, you can do things like integrations. You can go to Analyzer. You have seen that in the last webinar, I think, about the CFD Analyzer, how you could do an integration over the slice. You would extract it, and if you do that integration over time, then you get a curve, a line, which is showing for example, the mean value on the slice over time. But what if you would like to know the mean values over the complete slice for every point of the slice? So here, no standard function in Tecplot is available. And what I will do now is simply to start my macro. I go to the quick macro panel. I have here slices over time. So I just click here twice. The mean value for which variable, the pressure is number 4. And after some seconds, you see this is now the macro has executed. This is the plot of the mean value for every point on this slice over time. So once again, a macro helped you very much, and in this case, I placed it in the quick macro panel. Well, so back to my presentation. Okay, and now let's speak about Tecplot Chorus and macros. Tecplot Chorus is a management center for Tecplot 360. If you would like to learn more about Tecplot Chorus, please see our webinar about it and let us know if you need a link to the webinar to learn what Tecplot Chorus is. Let's start Tecplot Chorus. Chorus 2016, and I load a prepared project where I have 32 cases. You see here the parameters, so it is it comes from a parameter study, and we would like to integrate now over a surface. What I'm doing is to load one of these data sets which are linked to these different cases. Tecplot will open. Now you see here sorry, this UAV, and what we do is to place a slice, but now we directly begin to record a macro. So record macro, then I go to the project directory, which is under data, UAV, Chorus derived macro templates. Let's call it int.mcr, for example. You see here, int.mcr. Now we place the slice. Yeah, let's say that this position is the right one, and we extract now the slice, extract current slices, extract, then analyze, perform integration, for example an average integral over the pressure. That's it. Now we integrate, and that's it. We are ready. We can stop the recording. I can close Tecplot. And now this integration is available to Chorus, and we can get back. And that's the point. That's so interesting. We can get back the integration results to Tecplot Chorus to work further with them. Yeah, let's save some time and mark only 5 data sets, and let's apply the integration. I go to extract variables. I choose the int macro, click on OK, and after a couple of seconds this job should be done. The integration should be finished. You see here now the green light, it's finished. And now we deposit, meaning we place the integration results to our database. In this case, it's something like mean pressure. Well, done, finish, and here you see now the mean pressure values. And for all of the calculations I did not perform, you see null. Yeah, so here are the integration results given back to Tecplot Chorus. Okay, that's it about Tecplot Chorus and macros. And Tecplot, just ask our support. You can email to support@tecplot.de, but I would say that you simply call us, and this would be the main number here, and just ask for support. You get support with online meetings additionally. You will have additionally webinar trainings which you can join for free, or just ask us for personal training, which may be possible too. Why not? If you have some ideas, problems about Tecplot, just let us know and we can set up a new webinar. We have something new. We have a free Tecplot certification, which means that you do some work. It's around 1 hour, and after this, you complete the certification and you get via post, via mail from us, a handwritten certification about that you have skills around Tecplot. Okay, that's it. Thank you very much. I'm Jens Warkal from Genius Graphics. Contact me for more information, and we will stop now the recording of the video